Hey calculus, let's go through differential equations. Okay, the first step is to separate the variables. All right, so we separate the variables. What does that mean? It means all the y's and dy terms are on the left, and all the x terms and the dx's are on the right. So that's our first step. So for number 1, there's a dx on the left-hand side. This dx needs to move over here. It's in the denominator, so we simply multiply both sides by dx. So I'm going to put dx over 1 here, and I'm going to put times dx on the right. Now, on the left, these cancel out. I have 1 dy. There's a 1 there, even though it's not written. And on the right, I have 2 dx. So that's my first step. The second step is to integrate both sides. So what does that mean? We put an elongated s on this side, and we put an elongated s on this side. Okay, so now we take the antiderivative of both sides. The antiderivative of 1 is just y. The antiderivative on the right side of 2 is simply 2x. The 2 comes along for the ride, 2x plus c. And that is as far as we need to go. All right, let's go to number 2. All right, first step, separate the variables. This dx has to come over to the right. So that's the only thing we need to do. We're going to multiply this side by dx over 1 and multiply this side by dx. These cancel. I have 1 dy is equal to 2x dx. So there's my first step. Now I integrate both sides, antiderivatives. The antiderivative of 1 is just y. On the right-hand side, 2 comes along for the ride, and the antiderivative of x to the first is x squared over 2. That is the power rule for antiderivatives, plus c. So that simplifies to y is equal to, these cancel, x squared plus c. That is as far as you need to go. All right, let's look at number 3. The first thing we're going to do is we are going to move this term over to the right. This is minus 3x squared, so we are going to add 3x squared to both sides. So we have dy dx on the left, and on the right we have 3x squared. Now we simply have to multiply both sides by dx to move that dx over to the right. So I'm left with, on the left, I just have 1, of course, times dy, and on the right, I have 3x squared dx. So there's my first step, separate the variables. Now I integrate. Again, the antiderivative of 1 on this side is just y. On the right, the antiderivative of 3x squared, well, the 3 comes along for the ride, and that gives me x to the third over 3 plus c. And then we simplify. We have y is equal to, the 3's cancel, and I have x cubed plus 3. Hello, not plus 3, plus c. All right, here we go. All right, so those first 3 hopefully were pretty simple. Again, hopefully you're trying these on your own first. All right, let's keep going. Number 4. All right, the first thing that we need to do is move over the dx. That's really the only thing that needs to move. So I'm going to multiply this side by dx over 1, and I'm going to multiply this side by dx. So this cancels out here. That's a y over 1. So on the left, I have y dy. On the right, I have x minus 3 dx. So now I integrate. All right, well, the antiderivative of y to the first is going to be y squared over 2. Y to the second over 2. On the right, we take the antiderivative of each term. The antiderivative of x to the first is x to the second over 2. And the antiderivative of negative 3 would be negative 3x plus c. Now we just simplify. There's a 1 right here, so we pull that out and we write this term here as 1/2 y squared. Same thing here. There's a 1 right here. So we pull that out and we write that as 1/2 x squared and then minus 3x plus c. Okay, so there is our final answer. You only have to get the term with y in it by itself. So that's as far as you need to go. All right, let's get going on number 5. The first thing that we have to move over is this dx. So we're going to multiply both sides by dx over 1. All right, so now on the left I have dy. On the right I have 3y dx. Okay, now I need to move this y over to the left. I'm going to leave the 3 here simply because it's going to be easier, and you'll see what I mean in a few minutes. So this this y, we're going to divide both sides by y. So on the left, this is the same as 1 dy, so I'm going to pull this out front, and I'm going to write that as 1 over y dy, simply because I know the antiderivative of 1 over y. I don't know the antiderivative of a fraction. Okay, on the left, these y's are going to cancel out, and I just have 3 dx. So there my variables are separated. Okay, now we integrate both sides. The antiderivative of 1 over y, that's our flashcards. We get ln, absolute value of y. And on the right, the antiderivative of 3, of course, is 3x to the first. And then plus c. Okay, now we have one extra step. We need to get rid of this ln in front. We have to get the term with y in it by itself. So to get rid of ln, we exponentiate both sides. And that means we simply make e the base on both sides. Exponentiate. Why do we do that? Because here on the left, e and ln cancel each other out. And we are left with what's left. So we're left with the absolute value of y. Okay, now on the right, our c is in the exponent. So now we're going to rewrite this side using exponents. So it's going to be e to the 3x times e to the c. This right here is equivalent to this, because when we're multiplying two exponents that have the same base, you always add. Now this right here is a constant. This is our c. So that's really as far as we need to go. Okay, so the absolute value of y is just y. It makes it positive. I'm going to put this out front because that represents our c, our constant. So e to the c times e to the 3x. That is as far as we need to go. You could also write it like this. C times, I'm sorry, this is supposed to be e right here. Thank you very much. It's late at night when I do these because my kids are asleep. All right, so anyways, the other way we could also write this is c times e to the 3x. All right, those are my perfect answers. All right, let's go. Number 6. All right, let's separate the variables. We have to move the dx over here. So we're going to multiply by dx. So these cancel. I have dy. 1 dy is equal to 2xy dx. Now I need to move this over, so I have to divide both sides by y. And again, I'm going to pull this out, so I'm going to write the left-hand side as 1 over y dy. And on the right, these cancel, and I have 2x dx. All right, now my variables are separated. Now I am ready to integrate both sides. Big elongated s. Now we take the antiderivatives. The antiderivative of 1 over y is, again, ln, absolute value of y. On the right, the antiderivative of 2x is 2x to the second over 2 plus c. Now these are going to cancel, so that leaves me with ln, absolute value of y, is equal to x squared plus c. And now again, we have to get rid of the ln, so we exponentiate. We make e the base. All right, now these cancel. I have absolute value of y on the left. I'm going to rewrite this side again using exponents. So it looks like this, e to the x squared times e to the c. Those right-hand sides are equivalent, and now I simply just put the c in front. E to the c times e to the x squared. Or if you like it better, you can write this right here is our c. C times e to the x squared. Either of those is acceptable. All right, let's go to number 7. Okay, the first thing I need to do, of course, is move the dx over. So multiply both sides by dx. These cancel. I have 1 dy is equal to negative y cubed dx. Now I need to move this over here. So I'm going to divide both sides by negative y cubed. Negative y cubed is in the denominator. All right, on the left, I'm going to rewrite that as 1 over negative y to the third dy. Pull that out front. These cancel. On the left, I simply have 1 times dx. There's still a 1 here. It doesn't cancel out. Okay, now we're ready to integrate both sides. Big elongated s. Now, I don't know how to take the antiderivative of a fraction, but I can rewrite this right here. Okay? If I move this right here up to the numerator, the sign of my exponent changes. So it looks like this. I have negative y to the negative 3 dy is equal to 1 dx. Again, so I just move this term up. There's a negative out front here, and that 3 becomes negative. Now I'm ready to finally take my antiderivatives. This is going to be a power rule. So the negative, when I take the antiderivative, this negative 1 comes along for the ride. When I add 1 to this, negative 3 plus 1 is going to give me y to the negative 2 over negative 2. And then on the right-hand side, the antiderivative, oops, I forgot the elongated s here, can't forget that. But now when we take the antiderivative of 1, of course, is just x plus c. All right, and now I can rewrite this. Here, a negative and a negative becomes a positive. There's still a 1 out front here, so I can rewrite this as 1/2 y to the negative 2 is equal to x plus c. And then, if I wanted to, I could rewrite this. I could move this negative down. I can move this y to the negative 2 down to the denominator, and it would look like this. 1 over 2y squared is equal to x plus c. All right, so that is without a negative exponent, and this over here is with a negative exponent. Make sure you know how to move this downstairs. Okay, and then one more for the front side of this guy. Number 8. Okay, separate the variables. We move dx over to the other side by multiplying by dx over 1. So these cancel. I have 1 dy is equal to 2x plus 1 dx. That's all I need to do to separate. Now I integrate both sides. The antiderivative of 1, of course, is y. On the right, the antiderivative of 2x is 2x to the second over 2. And the antiderivative of 1 is x to the first plus c. And then I simplify. Y is equal to, those cancel, x squared plus x plus c. Okay, hopefully these first 8 problems weren't too bad and you're getting those first 2 steps down. Separate and integrate. Now we're going to go to the back side and dial up the difficulty just a tad. All right, see you on the other side.